In this video, we will cover lists. First, we will see how to access the elements of a list using indexing and slicing. Then we will see how to change the elements of a list. And at the end, we will see list methods and list comprehensions. Now let's open a Jupyter notebook and start coding. Let's see some list examples. I will start with an empty list. Empty list will be equal to just this one. Open and close brackets. Let's see a list of integers. I will call it numbers is equal to 1, 2, 3, 4, 5, and 6. This is a list of numbers. Let's create a list of strings. Text is equal to hello world. I use Python. This is a list of strings. Let's create also a mixed list. My mixed list is equal to open brackets, and I will write an integer and a string, another string. Let's write one more integer, a float, and we can also put booleans in it. We can also have nested lists. That means lists inside of lists. Let's create one nested list is equal to open brackets, open one more, and put a list in it. This is a list, and this is another list of strings. Hello world. And we can also put another one in it. Well, 15, and this is a nested list. Now let's see indexing of lists. Let's take this numbers list, copy and paste it in here. See it more clearly. The indexing of lists starts from 0. So this is the element at index 0, and it goes increasing by 1. Since it is starting from 0, the index of the last element of a list will be the number of elements on a list in a list minus 1. So let's check it. This is 0, index 0. This is 1, this is 2, 3, 4, and this is index 5. Let's see how to reach the elements by calling the index number. I will write the name of the list, open brackets, and I will write 0. So this will give me the first element of the list. Let's run this cell. As you see, it gave us 1. Okay, let's create another cell. Call numbers index 5. If I run this, I will get the last element in this list. Let's try to call numbers 6 at index 6. And this is going to give me an error because this is out of range of this list indexes. Why? Because since it is starting from 0, the last elements index is length of the list, which means the number of elements in the list minus 1. So this is out of range. Let's comment this out, run this one more time, and continue. Let's take this text list, copy and paste it in here. Okay, now let's reach the elements at index 1 in this text list. If I run this, I'll guess world, because this is index 0 and this is index 1. So index 1 is the second index, gives us the second element on a list. Okay, let's create another cell. Let's take the first element of a list by calling index 1. This gives us hello. And let's get the last element of this list. How can we do that? This has 1, 2, 3, 4, 5 elements on the list. So if I call 4, which is number of elements in the list minus 1, this will give us the last element of the list. There is a better way to get the last element of a list, and it is negative indexing. Let's call texts minus 1. If I run this, I will get the last element of this list. And this is very useful actually, but it is starting from minus 1. Normal indexing starting from 0, and it's starting from -1 and it goes -1, -2, -3 like this. Let's create another cell and call texts -2. Okay, if I run this, I'll get use. If I create one more cell and call texts -5, I will get the first element of this list because it is in the 5th position from the end. Okay, let's try to call texts -6 in here. And if I run this, I will get an error because this index is out of range. Okay, let's comment this out and start slicing. Slicing is accessing a subset of elements of a list. Let's take this numbers list one more time. Copy and paste it in here. I will write numbers, brackets, and put a column in it. If I run this, this is the symbol used to slice a list. And since we didn't write anything before and after this gave us the full list again. Okay, let's create another cell. If I write numbers, open brackets, 2 and colon, this will start from index 2 and give the rest of the list to us. Let's run this. Okay, this gave us 3, 4, 5 and 6. This is index 0, this is 1 and this is 2. It started from this one, index 2, and gave us the rest. If I write numbers and I will start with a colon this time and end with a statement and with an index. Okay, if I run this, this behavior will be a little different than this because the starting index is inclusive but the ending index is exclusive. So this is not going to give us the element at index number 3. It will it will stop just before that. So it is 1, 2, 3 element index at 0, 1 and 2. The element at index number 3 was 4. It didn't give us 4. Okay, let's combine them together. I'll write numbers and it will start from index 0 and end at index 4. If I run this, this will start from this, which is element 0, 1, 2, index 2, and it will give us element at index 3, but it will not give us the element at index 4. Okay, if I run this, I will get 3 and 4 from this. We can also do the same with negative indexes. Let's write numbers, colon, -2. This means start from the beginning and give me the list, subset of the list until the element at index -2. Okay, what was at index -2? It is 5 because this was starting from -1, right? -1, -2. Since this is the ending index, this is exclusive, so this is going to give us the list from the part of the list like this. This will not give us the element at index -2. Okay, if I run this, I'll get 1, 2, 3, 4, and this is all. Okay, now let's see how to change the elements of a list. To change an element of a list, we will get the element by indexing, and after that we will just assign a new value to it. Let's take this numbers list one more time. Okay, now let's write numbers, and I want to change the elements at index 1, the second element of the list. I will call numbers 1, and I will assign a new value to it, let's say 40. And if I call numbers list in here and run this cell, I will get 1, 40, 3, 4, 5, and 6. This element at index number 1 is changed to 40. Let's see one more example with the list of strings. I will copy this text list and create one more cell in here. Okay, now let's change this language in here. I'll call texts. This was index -1, right? Let's write -1 in here, the last element of the list, and I will assign a new value to it. I'll write Java. Okay, if I call this text list in here and run this cell, this time hello world, I use Java. Okay, let's call numbers. Here it was 1, 40, 3, 4, 5, and 6. Now I'm going to change a subset of the list by using slicing. Let's write numbers from index 1 to index 4. This is inclusive, this is exclusive, right? Okay, so this is going to start from this one and it will take this and this. This is at index 3, this is at index 4, this is not going to take this. So I am calling this part of this list by writing this expression. So I am going to assign a new value to it. Since it's a subset of a list, it is a list, so I'm going to uh, put a list in here. So I write a string expression in here, list of strings actually, A, B, and C. Okay, now if I call numbers one more time in here, those three elements of this numbers list is changed to this list that I have assigned to it. Now we are going to take a look at some built-in methods of lists and see some examples of them. Let's start with append. Append adds a new element to the end of the list. Let's define our numbers list one more time. Numbers is equal to 1, 2, 3, 4, 5, and 6. Okay, now I'm going to add a new element to this list by using append method. Numbers.append, and I will write 7 here. If I call here numbers one more time and run this cell, as you see now we have added one element in this to this list. Okay, let's see extend. Extend adds elements or another list to the end of the list. Let's take a look at this numbers dot extend, and I'm going to put some more elements in here, 8 and 9. Okay, if I call numbers one more time, run this cell, as you see those two have been added to this list. Let's create another cell, and now I'm going to define another list in here. I will call it additional numbers. This will be 10, 11, and 12. Let's extend numbers one more time, numbers.extend, and I'm going to put this list directly in here, additional numbers. And if you call numbers again and run the cell, as you see new lists elements now have been added to this to numbers list. Okay, let's see insert method. This method inserts an element at a specified index. Let's take this numbers list in this form one more time. Okay, now let's write numbers dot insert. Okay, first I'll write the index that I want to put the new element at, and I'm going to put it at index 1. So it is going to be in here. And I'll write a string in here. I'll write 100, and let's call this and run this cell. As you see, the new element has been added to index 1, and the element at index 1 and the values beyond will be shifted to the right. Okay, now their indexes are increased by 1. Let's take a look at some indexes, numbers, and I will call index 1 and run this. I'm going to see the new value in here, and 2 was at index 1 at first, but we have added this one, so 2 is shifted 1 to the right. Okay, now if I call numbers index 2 and run this, I'm going to see this value, which is this one. It is shifted 1 to the right. Okay, now let's see remove methods. Remove basically removes the first occurrence of the specified value. Let's paste this numbers list again, and I'm going to add one more 3 at the end. Let's write numbers.remove, and I write 3 in here. This is not the index, this is directly the value. So this is the first occurrence. So if I run these numbers, I'm going to see that this tree is removed from the list, but this one is still there because it just removes the first occurrence of the specified value. Okay, let's create one more cell. I will write numbers that remove tree again, and I will call numbers one more time, and now this tree at the end of the list is also removed. If I call this one more time, numbers that remove tree, let's call numbers again. If I run this, I'm going to see an error in here because there is no more tree value in the list. Okay, let's comment those out. Run this one more time to remove the error from there and see pop method. Pop removes and returns the element at the specified index. We are going to see what return means in detail in function section, but for now just know that if a method or function returns something, that means you can assign it to a variable. Let's see what I mean. By the way, if you don't write an index in pop method, it removes the last element by default. Let's take this numbers list again in here. Let's copy that, and I will delete this tree at the end. I will define a variable as deleted element, and this will be equal to numbers.pop. I'm not going to write an index here, so it is going to delete the last element, and since it is returning this deleted value, this deleted element will be 6. Now let's print deleted element and also print numbers list. Okay, run this. As you see, this deleted element is 6, which is at the end. So since we didn't write an index in here, by default it is the last item. And now the numbers list is 1, 2, 3, 4, 5. Okay, now let's write an index and pop in this way. Numbers.pop. Let's write index. I'll write 3 in here. And if I run this directly, as you see, since this returned something, this returned the deleted element, which is 4 at index 3. And if I call numbers again in here, let's comment this out because this is going to run this one more time. If I run this cell again, let's run this. So I'm going to see that number 4 is deleted from the list. Okay, let's see clear methods. Clear deletes all elements of the list. This was numbers list at its last form, and if I call numbers, that's clear. Do not forget the parentheses at the end. And if I call numbers and run the cell, I'm going to see an empty list in here. It deleted all the elements from this list. Okay, let's take this list one more time and see index method. This returns index of the first occurrence of this specified value. Let's add one more 5 at the end of this list, and I'm going to define a variable in here, index of integer 5, and I'm going to assign numbers.index to it. Okay, and I'm going to put 5 in here. I will see the index of 5. There are 2 5s in this list, but this is going to return the first occurrences index. Let's call index of integer 5 and run this. We will see 4 in here. Let's see count method. Count returns number of occurrences of the specified value. Let's take this again. Okay, I'll call numbers dot count and 5. Okay, let's run this. This is going to give us 3 because there are 1, 2, 5s in this list. Let's create two more cells in here, and numbers.count. Let's count 1 in this list. Call this, we will see 1 because there is just one occurrence of integer 1 in here. And let's also call numbers 20. This will give us 0, not 0. What did I do wrong? I forgot to put count in here. This is going to give us 0 because there is no 20 in this list. Okay, let's see sort method. This sorts the list in ascending order, and you can change the order. We will see that. Let's define a new list in here, new numbers, and write random numbers in here. 1, 17, 14, and 0. Okay, I'll write new numbers, sort, and call new numbers again. And I'm going to see that the values are sorted in ascending order. Okay, now let's take this one more time. Actually, take those also. And I'm going to write here reverse is equal to true. If you do this, this is going to sort the list in descending order. Let's run this. I forgot to put E at the end. Run this one more time. And as you see, this is the in descending order. You can also sort lists, a list of strings. Let's see an example. Texts is equal to hello world. I use Python. Okay. Let's call texts dot sort, put the parentheses at the end, and call texts in here. As you see, this sorted the text strings in alphabetical order. Let's try a different thing. I will take this mixed list that we have defined at the beginning of this section, and I am going to try to sort it. Let's define it one more time, and my mixed list dot sort. If you call this, this is going to give us an error because those values do not have something in common in a way that they can be sorted according to that. Okay, let's comment those out. So this cannot sort different data types. Okay, now let's see reverse method. This is very straightforward. This just reverses the order of the list. Let's take a reverse list. Let's create something as reverse list, and I will add 4, 3, 2, and 1 in here. Let's call reverse list dot reverse, put the parentheses, and call reverse list again. And if I run this, I'm going to see that this reverses the order of the list. Okay, this was all for the built-in methods. Now we are going to see some useful list operations, and we will start with len list. This function gives the number of elements in a list, and it is very useful. Let's call texts again, hello world. And if I call len, open parentheses, and put the list inside of it, texts, and run this, I'm going to see the length of the list, which is the number of elements in this list. This is also very straightforward, and this is very useful. Okay, now let's see sum list. This sums the numbers in a list. Let's create another list in here. New list is equal to, open brackets, 7, 3, and 5, let's say. And if I call sum and put the new list in it, okay, run this, I'm going to see that the total of those three numbers. Max and min functions, they give the maximum and minimum values in a list. and they also work with strings. Okay, now let's write max new list that we have defined above. If I call this, I'm going to see 7. Okay, now let's create one more cell and write min new list. Run this. This is going to give us 3. Let's take this text from here, create one more cell and paste it. And now I'm going to use max and min methods for this text list. Max texts, and if I run this, this is going to give me world, which is the last element in the alphabetical order. Python takes it as the maximum of those values. And also if I call min texts and run this, I'm going to see I, which is the first element in the alphabetical order of this list of strings. Okay, let's see this list set list. This is a very useful function, and what is it doing is that it's taking a list in a set function, and in here the duplicate elements are removed from this list, and after that it takes them together in a list function, and it converts the set data type to a list data type. This because we want to use our list as a list at the end. Okay, let's see an example. I'm going to copy and paste something in here. This is a list, and there are some duplicate elements like 1 and 7, 7. There are 3 7s. Okay, let's write list, open parentheses, and put a set function in it. And I'm going to take my list and paste it in here. Okay, this is going to remove the duplicate elements, and this is going to, this list is going to convert the data type to a list from set. Let's run this, and as you see, it also ordered the items, and the duplicate elements are removed from this list. Let's see range function. We use range a lot in Python, especially with the for loops that we are going to see in later sections. They used to generate a sequence of numbers, and the most common use case is we use them to loop for a number of times that we decide. Let's see some examples of them. And I write range 5, and if I run this, this gives us a range object. It is starting from 0 and ends at 5. You can define a starting point, but if you don't, it is 0 by default. Let's write another one with a starting point 0 to 5. If I run this, I'll get a range object from 0 to 5. Now I'm going to put this in a list to see what it does, what this range function does more clearly. My range list is equal to a list function. I'm going to convert this in a list. Okay, let's call my range list. If I run this, I get a list from here. And if you notice, this is very similar to slicing. The starting point is inclusive, but the ending point is exclusive. So it started from 2, but it didn't take 5 at the end. It took all the numbers until 5, and it didn't include 5. Okay, let's see one more usage of this. I will copy and paste this in here, and this time I will start from 1 and I will go until 40. Okay, and I will add one more attribute in here. I will write 3 at the end of this range function, and this is the step size. Let's run this, and as you see, this gave us the numbers from 1 to 40, 40 exclusive, and the step size is 3, so it is not going 1 2 3 4 5. It is going like 1 4 7 10 and 13, and it's going on like this with a step size of 3. And as you see, this is a very useful way to create sequence of numbers. Now let's see list comprehensions. List comprehensions is a way to create new lists from existing ones by applying some expressions to every item of the existing list, or iterable or a range function. Let's see what I mean. First, I will define a numbers list, and I'm going to use a range function to do this. 1 to 5. Okay, this will give me 1, 2, 3, 4, as you see. Now I want another list, but this time I want this numbers lists items to be squared. Okay, let's write squares is equal to, and I am defining it as I am defining a list with brackets. Okay, then I write x squared. You can write anything you like, as you are defining a variable, and this expression will be similar to English actually, if you notice it, if you pay attention. Let's say x squared for x in numbers. Okay, if you run this, let's see, we will get all items of this list squared, and this is saying that for every x in this numbers list, take x's square. Okay, this is doing that. This may seem a little complicated to you right now because you didn't we haven't covered for loops yet, but when we see for loops, this will be very understandable to you. Okay, now let's create another one to see the power of list comprehensions. This time I will take cubes, and let's write this, let's use a this time, a cube for a in, this time I will use a range function. Okay, and I'll write 300 in here. It's not 1000, write hundreds. Okay, if I call cubes in here and run this cell, as you see, this gave us all the numbers cubes until from 0 to 300. Okay, this is a very useful way to create new lists from existing ones or from range functions, and we will understand them better when we see for loops in later sections. Okay, this was all for lists.